Welcome to this video on transforming and combining random variables. So I'm using a sample set that we used previously on the number of hours of sleep, and I want us to try some different transformation. There's rules that we had talked about previously, and we're going to apply those rules. Okay, so if you'll take your calculator and put all of these numbers into list 1 and run one variable statistics on them, you will get a mean of 6.4, a standard deviation of 1.51, and a variance of 2.28. So remember, the variance is just the standard deviation squared. So I'll write that up here, variance. Okay, now if we're going to take the number of hours of sleep and convert them to the number of minutes of sleep instead. So instead of hours, we want minutes. What we would need to do is we would need to take these values and multiply them all by 60 to get the number of minutes of sleep. But we have some rules that we can apply here. If we want to multiply or divide a distribution, what will happen to the mean is you will multiply or divide the mean by that number. I'm going to call that number A. So in this case, the A value that we're talking about is 60. So to get the mean number of minutes of sleep, I'll just take the mean number of hours of sleep times 60, because that will convert from hours to minutes, and that will give me a mean number of sleep of 384 minutes. Okay. For standard deviation, the same thing's going to happen. Whatever I'm going to multiply or divide by, that's what I'll multiply or divide by to my standard deviation. So it's still that 60 minutes that we were talking about. So I'm going to take my standard deviation and I'm going to multiply it by 60, and I get a new standard deviation of 90.6. Now, pay attention here. To get the variance, okay, the variance, remember, is the standard deviation squared. That's what this is saying, standard deviation squared. So this number has already been squared. So when I go to multiply it, whatever I multiply it by is going to also have to be squared. So they have the same transformation occurring to them. So I'll have to use 60 squared here because the 2.28 is a squared number, and that gives me 8,208 for my variance. Okay, so we're going to multiply for the variance or divide by whatever we were multiplying by, but it has to be squared so it matches the units of what we had already done. Okay. So that's multiplying or dividing. You'll multiply the mean and the standard deviation by whatever you're multiplying by to get the new mean and standard deviation. And you'll have to square it when you do the variance, because the variance is a squared number. But what if we're adding or subtracting? I was feeling generous and I said, hey, I know you're tired. Let's take a 20-minute nap. So I'm adding 20 minutes of sleep to your sleep time. So when you're adding or subtracting, you're going to add or subtract to your mean whatever that value is, and I'm just going to call it B. That's just the number I'm going to add or subtract. In this case, we're adding 20 minutes, so that's my B value that I was talking about. So we can just add 20 minutes. So now our average sleep time is 404 minutes. Now, for our standard deviation, when you're adding or subtracting, you're not changing the relative distance between the numbers. They're staying the same distance apart. They are just kind of like picking up and shifting and being put down at the new number 20 minutes later. So there's going to be no change for my standard deviation because the relative distance between the numbers does not change when you're adding and subtracting. By the same logic, there'll be no change in my variance because the variance is just the standard deviation squared, so there'll be no change here either. So that means my standard deviation is 90.6 and my variance is 8,208. Okay, so maybe the variance doesn't make a lot of sense when we're just kind of talking about one set of data, but it comes into play when we start combining our sets together. So what if I had information from both first period and second period, and I wanted to find out what happens if I combine their distributions, or if I find the difference in their distributions. Okay, so to find the mean of, if I want to combine these two distributions to find the new mean, I'm just going to add the means together. So it'd be the mean of x plus the mean of y. So in this case, that is 6.4 plus 6.2, which I just got from right here, which gives us a new mean of 12.6 hours. Okay. Now, for standard deviation, we don't work with standard deviation. We're always going to work with variances. So we want to square them. So let's go ahead and work with our variance here. So it's standard deviation squared. So it'd be 1.51 squared plus 1.98 squared, which when you put that into your calculator, you got a variance of 6.20. So remember, your variance is the square of the standard deviation. So if I take this number and I square root it, that's going to give me my standard deviation of 2.49. Okay, so that's if I'm adding the two distributions together. What if I'm subtracting the two distributions? So the mean works in a similar manner. The mean of x minus the mean of y will just be the 6.4 minus 6.2, so they have a difference of 0.2 hours. Now, let's look at our variances. Remember, it's your standard deviation squared, 1.51 squared, but we still have to add. So in this case, these work the same as when you were adding. Even if we're subtracting, this will be 1.98 squared, which will still give me the 6.20. That is not going to change, and here's why. When I do the standard deviation here, standard deviation is the average distance from the mean. If I did distribution x minus distribution y, I would end up with a negative standard deviation. You cannot have a negative distance, and so that's why we deal with the variances. Even when we're subtracting, we still have to add them. Okay, we don't want to have a negative number. And so that is the reason the formula stays the same whether you're adding or subtracting. And even when you look on your formula sheet, you will see that it's adding always the variances. So when I look here, when we were doing our test with our difference of means, right there, see how you're adding your variance even though you're looking for a difference of means. Okay, so that's an important point to remember there. So what I want you to take away from this, so this will also be 2.49, is you don't just memorize the rules for transforming the variables, be able to apply them. And I also want to make sure you remember, you do not add your standard deviations, you add your variances, and you always add whether you're finding the sum of two distributions or the difference between two distributions. Hopefully that was helpful. Let me know if you have any questions, and I'll see you in class.